hypothesis test. According to National Geographic research, the average US adult uses about 1,800 gallons per day. What we're going to do is we're going to compare that to college students from the sample I've been collecting. So I've had my students the last few years doing the National Geographic Water Footprint Survey to estimate their water usage. What do you guys think? Do college students use more, less, or I don't know?
Probably about the same.
About the same, probably less. So we have different opinions here. Anyone online want to give an opinion? What do you think? They use more, less? I don't know. About the same. Buddy?
I don't know, maybe about the same.
Maybe about the same. Okay. Let's see. Claim. Community college students, or let's say community college math students, which is pretty much most community college students, use about the same. Now, if they use about the same, then that means they don't use a different amount, right? So I could also say, AKA, don't have a different average. Yeah.
Would about the same be appropriate when they're very similar numbers but not the same numbers?
Yeah.
Okay.
Yeah, so don't have different average. Okay, so let's see, we're talking about a mean, not a proportion, so we're going to use mu for a hypothesis. So I have a mu, and then they just said it is 1,800. Now they said 1,805. I'm just going to call it 1,800. And then alternatively, it's not 1,800 because we don't have a less than or greater than here. So then I could say mu is not 1,800. And you have to have two hypotheses. One of these is the null hypothesis. One of them is the alternative hypothesis. Which is which? The null hypothesis, the first one or the second one?
No, the first one.
The first one, yes. So the null hypothesis has to have an equal. So it's either going to be an equal to, a greater than or equal to, or a less than or equal to. The alternative is either going to be a not equal to, a less than, or a greater than. So in this case, I would label the first one as H with a 0 for null, and then we put a colon in between. So that's the symbolic way to write the null hypothesis. And this one is, I usually call it HA. Sometimes they'll call the alternative H1. I like to use the A for alternative. So those are my two hypotheses and symbols.
So null is H0?
Yes. Yeah. So this one is the null hypothesis, and this one's the alternative. All right, significance level. 5%. Use the typical. Alpha equals 5%, 0.05. Okay, so once we determine what our hypotheses are and we know what the variable means, right, which I have stated above, it's the average water footprint in gallons per day of a US adult. That's what mu stands for here. And I'm comparing it to average water footprint gallons per day of college students, or community college students. So now we need data to see what happens here. Okay, so next step is we go find the data. And let's see. I did not share this data with you. Apologies for that. Copy it all. And then I'm going to go over to StatKey. And in StatKey, for a hypothesis test, it's either going to be a single mean or a proportion, and we'll also play a little bit with differences in means and proportions next class. So I'm going to go here for a single one. And then two things happen once I'm in here. I got to edit out their data or pick the right data set. Oop, wrong button. Go. Got a header. Yep. Okay. And then I have to adjust the null, right? It's not 98.6. In this case, it's 1800. And then now it's kind of like having a confidence interval. Then once I set those two things, data and null, then I generate. Okay. And I get this roughly bell-shaped curve here. The original sample was a little skewed, and so the sampling distributions are a little skewed there. So let's see what's next. Went to StatKey. And in StatKey, we got to find the right data. And then we have to set the null hypothesis. And then we generate a lot. And then the next thing we do is we pick the test that we want. Okay, which test am I going to pick here? Left, to, or right?
What was our hypothesis?
Hypotheses are that mu is equal to 1800 or mu is not equal to 1800. It's going to be a two-tail because we picked not equal. Yeah, so if it was a less than, it would go, we do a left test, right is greater than, right, less than is to the left, greater than is to the right, not equal means you got to do a two-tail test. So because of our alternative hypothesis, our test is two-tail. So alternative picks the test, and in this case, it's a two-tail test. All right, so back to StatKey, and then we'll draw a sketch of it. So I'm going to pick two-tail. Now that's not enough. I have not applied the sample data yet. Okay, my sample mean is up here, that 1859.85. I got to put that in there to get a p-value. Okay, so that's the next step. So let's see, that number is bigger than the mean. True. That's currently on the screen. Mean is about 1800, so I got to plug it in on the right because it's bigger. If it was smaller, I'd plug it in on the left. So I'm going to replace that number at the bottom with the sample value, 1859.85. Wait, keyboard. 1859.85, and I'm pulling that off the original sample there. All right, and then screenshot this and draw a sketch and explain it. All right, so again, first step, write down your hypotheses. You should write them down in symbols, and then you should also have some statements that explain what mu means in this context, right? So I have those above. Then in StatKey, we plug in the data, we set the null, we generate, and we pick the test we want. Next step is after we pick the test, right, and we decided for the test we were going for the two-tail, we have to enter the sample statistic. In this case, the sample is the X bar up there. So my X bar in this case was 1859.85. And based on that, I can get the p-value. The p-value is whatever appears up here by the red zones. If you have a two-tail, there are two red zones, you need both numbers. If it was a left tail, you just have one number up there too, like the first one we did. If it's a right tail, you just have one number. So in this case, my p-value is going to be the sum of those two numbers. So it's going to be 0.159, and they'll usually match pretty close, plus 0.159. All right, adding those up, I'm going to get an 8 and a 1 and a 3. So I'm getting 0.38 when I add those two numbers together. Question?
Will the numbers always be the same on either side when you use two-tail? Or are they sometimes be different?
They should be pretty close. They'll be almost exactly the same. Yeah, usually the 3 decimal places don't match, but sometimes one might be a 159, the other could be 158. It could vary slightly, but it shouldn't vary much. So again, what happens with a two-tail is you type your sample data on one side and StatKey mirrors it on the other side and then counts how many samples fit in each tail. And then it gives a proportion of those tails. So that's our p-value here. Our p-value is 31.8%. So what's our conclusion here? Well, to get your conclusion, if the p-value is small, just a reminder of what I talked about before. So if you have a small p-value, then that means you support the alternative. If you have a large p-value, then you can't support the alternative. Okay. We have a large p-value. It's bigger than the 5% significance level. So what that means is we don't have sufficient evidence to support the alternative hypothesis. That's called the decision. So there's two, oops, wrong way. There's two ways to state the decision. And decision one is we reject the null hypothesis. Rejecting the null implies that the evidence, meaning the sample data, supports alternative hypothesis. Decision number two is you fail to reject the null. And that means the evidence does not support the alternative. And then to write the conclusion, we have to take into account the p-value of the decision and whatever the parameter means. So in this case, where the evidence does not support our alternative hypothesis that they're different, they are close enough to be the same. And we don't have evidence that college students have a different water footprint than the average adult in the US. So my conclusion would look something like this. There is not sufficient evidence to support the claim. And the conclusion is always the same framework. There either is sufficient evidence or there's not. And then you state what the alternative hypothesis was. Okay, so in this case, there's not. And the claim is that community college students do not use do not have, I don't want to word that. I gotta look back at the beginning to figure out a good wording for that. Let's see. According to National Geographic research, the average US adult uses about 1,800 gallons per day. I should have wrote of water. That's important. And then the alternative is that community colleges have a different mean. So we have to say they don't have a different mean. Eventually. Okay, so let's see. There's not sufficient evidence to support the claim that community college students, all right, let's say I messed that up. have a different average water footprints. Than US adults. So again, either there is or is not sufficient evidence. And then the claim that comes next is just a statement of the alternative hypothesis. And that's the formula for a conclusion. Okay, now notice the decision is reject the null or fail to reject the null. We don't usually say we accept the null. Accepting it means you know for a fact it's true. All we have now is evidence that supports the average water footprint is about 1,800. Was our average exactly 1,800? No, it was a little higher, but not a lot higher. They weren't far enough apart to say they're on average different. Random variation in populations accounts for the difference is what we're saying here. All right, one more quick one and then we'll break. Let's go back and actually let's pick one of the data sets in StatKey. See what we got. New recording for this one.